Every capacitor is far from perfection. I would say the best capacitor is no capacitor. Even the best sort of capacitors that we have in a shootout, they are not flawless. The better capacitors are the ones that basically have the minimum amount of flaws. I have to hear one yet that does the minimum damage. In this in mind, I remind everybody again that we cannot improve a recording. We can only cause harm to it. The best sort of reproduction of a recorded material is the one when we reproduce it, we cause the minimum amount of harm. No passive component is perfect, and that includes capacitors. Capacitors have the tendency to remove not only low-level musical information, but they also remove energy. They take energy out of music. Little bit by little bit, if you put more capacitors in series between different gain stages, the signal degradation increases cumulatively. The sound degradation that happens is so significant that you feel like, why do I have a capacitor there? Do I need a capacitor there? When we have a digital filterless DACs, so the only thing they have is an analog filter. So that capacitor in analog filtering function that removes so much energy is beyond comprehension. Sometimes one needs to remove certain amount of energy that one doesn't want, and that's the idea. So preserve the signal as much as we can and remove everything, all the undesired side effects around the signal as much as possible. So that's the whole objective or the goal of the undertaking. We've done that so many times, and now just wanted to present it to the public so the public can see how actually time-consuming and difficult it is to pick the right materials, so that in the end you have a product that is sounding convincing, that reproduces the music in such a fashion that humans find it enjoyable. There's no way you can measure this. The only way of measuring this is the human itself. Is the human enjoying the music? Is the human enjoying the music over longer periods of time? Does the sound that is being reproduced, or the music that's being reproduced, does it come across in a convincing fashion? That's what at the end matters the most. And everything else is, well, it's just means to an end. I lost the count how many times we basically did sort of shootout comparison, A/B comparison, different materials and components. But this is the first public recording of the shootout. I hope it's helpful to everybody in terms of to understand the sound characteristics of certain materials and capacitors. All this undertaking is to showcase that the sound of materials matter. I mean, a great analogy here is when a musician picks an instrument, a guitar player that chooses his guitar, you know, he's certainly tried different guitars. So it's not just adjusting the strings, right? So they are nice in tune and the sound according to the notes, but also that material the guitar is made of gives a certain character to the sound. No musician measures a freaking guitar. They pick the guitar they like the most, that represents their preference, how they see and hear that sound. Well, pretty much the same happens when we play back the music. The whole idea of the shootout was to display the variety of passive components and their effect on sound. Everybody tries to pick and say in the comment section, saying, oh, this is a close one, they all sound similar, oh, I probably go with the capacitor B. Oh, no, it's A this time. Well, there you go. This is the difficulty behind the whole process. One needs to sit down, listen carefully, see how it sounds with different sort of music, how does it affect you, do you like the sound, do you don't like the sound, is something missing? So that needs to be taken into account if one is serious about building audio equipment that reproduces music at its highest potential. I hope this is beneficial and information is going to be helpful to many people in the DIY community, and I'm happy to share my experience with all the people who are interested in the subject.